Welcome to another deep dive, and this one's gonna get kind of wild.
Yeah, buckle up.
What if the universe isn't just, described by math, but actually is math?
Yeah.
We're diving into physicist Max Tegmark's book, Our Universe is a Math Problem, to explore that very idea.
It's a bold claim, that's for sure. It's like saying the blueprint of your house isn't just a representation, it is the house.
I know, I can kind of get how math is the language of physics and all that, but
Yeah.
but Tegmark takes it a step further, right?
Exactly.
He says everything, like this conversation we're having.
Yeah.
It's all equations at the most fundamental level.
Yeah, exactly. Tegmark's argument is that the universe isn't just, described by math. It fundamentally is a mathematical structure.
Okay, so help me wrap my head around this.
Okay.
If I look at a tree, I see bark and leaves and, sunlight filtering through.
Mm-hmm.
How does that translate to equations? What does that even look like?
So think of a video game, right? The characters, the world, everything you see interact with is built from code. But to the
Right.
characters inside the game, it feels like a real world, right? Like a tangible world.
Sure.
It's the same with our universe, except instead of code, it's math. That's the underlying,
Fabric.
fabric.
Right.
Yeah.
So instead of pixels and polygons, we're talking numbers and equations making up the fabric of reality.
You got it. And the amazing thing is, this isn't just some philosophical daydream, If the universe really is fundamentally mathematical, think of the possibilities.
Yeah, where do we go with that?
It could give us incredible predictive power. It could be like unlocking a cheat code for the universe.
Oh, wow.
Like imagine predicting earthquakes or harnessing new energy sources purely through mathematical principles.
Okay, now that's where things start to get really intriguing.
Right.
Maybe a little unnerving, too.
Yeah.
This whole mathematical universe idea seems to really go hand in hand with this whole concept of the multiverse, doesn't it?
It does.
Like, are we talking about a reality where there are infinite parallel universes
Yeah,
and they're not just possible but inevitable?
absolutely. If you take the mathematical universe hypothesis seriously, then yeah, the idea of a multiverse becomes pretty much unavoidable. And Tegmark doesn't just stop at a multiverse. He lays out 4 distinct levels of multiverses.
Okay, so lay it on me. What are these different multiverse levels?
Okay.
And how wild does it get?
Well, level 1 is the easiest one to visualize.
Okay.
Just picture our observable universe, right?
Mm-hmm.
But infinitely bigger. Now, within that massive expanse, there would be regions that look pretty much exactly like ours,
Yeah.
with planet stars, maybe even other versions of you and me
Oh, wow.
out there somewhere.
So an infinite expanse of copies.
Yeah.
But they're so far away we could never reach them.
Right.
That's kind of comforting, actually.
Hmm?
Like a cosmic safety net?
Yeah.
What about the other levels? Do they get weirder?
Oh, yeah, they definitely get weirder. So level 2 gets into universes with different laws of physics themselves.
Whoa.
So imagine a universe where gravity is weaker or the speed of light is faster.
Okay.
The very building blocks of reality would be different, leading to completely different stars, galaxies, who knows what else.
So physics gone wild. It sounds like science fiction.
It does sound like science fiction, but there are theoretical frameworks like string theory that suggest the possibility of these different physical laws. And when you combine that with the mathematical universe idea, it starts to become, well, a little bit less far-fetched.
Okay, you've piqued my curiosity. What about level 3? You said it gets even weirder.
Yeah, this one's rooted in quantum mechanics, which is already pretty mind-bending.
Yeah.
The basic idea is that every quantum event, every tiny decision a particle makes, splits reality, creating tons of parallel universes branching off constantly.
Hold on. Are you saying there are countless other versions of me out there making different choices at every moment?
Pretty much, yeah.
That's a lot and kind of overwhelming.
Yeah.
Makes you wonder what if I'd gone left instead of right this morning.
Right. It's a wild consequence of taking quantum mechanics to its logical extreme. Every choice you make, every path not taken could exist in another universe. It makes you think about free will and what it means to be you.
Okay, my brain needs a break.
Yeah.
But we're not done yet, are we? You mentioned the level 4.
Oh, yeah, we got to go to level 4. So that's where we push this whole multiverse concept to the absolute limit.
Okay, give me.
It proposes that every mathematically possible structure exists as a real universe. We're talking universes with different dimensions, different logic, even universes where math as we know it doesn't apply.
So basically, if a mathematician can dream it up, it exists out there somewhere.
Yeah, pretty much.
That's profound. But honestly, it's hard to even wrap my head around what that would look like.
Yeah, it takes us to the very edge of what we can even comprehend about the nature of reality.
For sure.
But maybe before we get totally lost in the infinite possibilities of the multiverse,
Right.
let's bring things back down to Earth a little.
Please, my head is
Uh,
spinning. Where do we go from here?
Okay, so let's talk about cosmic inflation.
Okay.
You see, this theory is super important when we talk about the origins of the universe and this whole idea of a multiverse.
Yeah, I remember learning about cosmic inflation in school. It explains how the universe expanded super fast, like ridiculously fast right after the Big Bang.
Exactly.
But how does that tie into the multiverse idea?
Well, some models of cosmic inflation actually suggest that this rapid expansion could have happened multiple times,
Really?
creating a bunch of other universes in the process. It's kind of like bubbles forming in like a boiling pot of water. Each bubble is a separate universe.
So you're saying there's evidence of the multiverse baked right into the beginning of our universe?
It's a fascinating possibility, but we have to be careful here. While inflation explains a lot about what we see in the universe, its uniformity and patterns in the cosmic microwave background radiation, actually directly observing evidence for inflation, let alone the multiverse, is really challenging.
So the hunt for evidence continues.
Oh, yeah.
What would that evidence even look like?
Well, scientists are looking for these very specific patterns in the cosmic microwave background radiation that could indicate other universes colliding with ours during inflation. It's like trying to find a tiny ripple in a vast ocean.
Right.
But the technology is always improving, so who knows what we might find.
That's what I love about cosmology. It's always pushing the boundaries of what we thought we knew. But let's shift gears for a second.
Okay.
We've been talking about all these mind-blowing possibilities in the multiverse.
Right.
But what does it all mean for us here on Earth? Where do humanity fit into this whole grand cosmic picture, especially if we are just one of many universes?
That's a big question, one that Tegmark spends a lot of time with in his book. And if we do accept the mathematical universe hypothesis and the idea of this vast multiverse, then it really raises the possibility that intelligent life like us might be incredibly rare, maybe even unique in the observable universe.
Wow, that's both exciting and terrifying.
Yeah.
I mean, it makes you feel pretty special, right? Like
Yeah.
humanity is this precious anomaly in the cosmos. But what if we really are alone out here?
It is a lot of pressure, but it highlights the importance and fragility of life as we know it. And Tegmark argues that given our unique position, we have a huge responsibility to explore, understand, and preserve not only our own planet, but the entire cosmos.
Yeah, if we're the only ones out here asking these big questions,
Right.
it's on us to find the answers.
Yeah.
It almost feels like a cosmic imperative. But what does that look like practically? It's easy to talk about cosmic responsibility, but how do we actually live up to that?
Well, Tegmark argues for a fundamental shift in our scientific and societal priorities. It's not just about exploring for the sake of exploring anymore. It's
Right.
about approaching our role in the universe with a sense of stewardship.
Stewardship. I like that.
I-
So it's not just about finding out what's out there, it's about taking care of it too.
Exactly. If we
Right.
really are rare and precious, then we have a duty to preserve and nurture the knowledge and beauty we find.
Oh.
And that extends beyond just space exploration. It's about how we treat our own planet, how we develop sustainable technologies, and how we ensure the long-term survival, not just of humanity, but of all life on Earth.
It's interesting, we started this deep dive talking about math and the nature of reality, and now we're talking about sustainability and ethics. It seems like these big cosmic questions always lead us back to these very down-to-earth concerns.
They do. And it makes you realize that understanding our place in the universe isn't just about abstract knowledge, it's about making choices that will shape the future of life itself.
Yeah, and what are some of those choices specifically?
Yeah.
What does Tegmark say we need to do differently, both in terms of science and as a society?
Well, on the scientific front, he says we need to support a wider range of research. It's not enough to just focus on these big, flashy projects like searching for gravitational waves or dark matter. We also need to fund the smaller, more innovative experiments that might seem outlandish at first, but could lead to huge breakthroughs.
So don't put all our cosmic eggs in one basket.
Hmm.
Okay, makes sense. But what about the societal side? What can we do as individuals and a global community to embody this cosmic responsibility?
Well, that's where things get tricky. Tegmark doesn't really give any easy solutions, but he emphasizes the need for greater global cooperation and long-term thinking.
Right.
We need to start thinking about the impact our actions have, not just on ourselves, but on future generations, and even the universe as a whole.
It's a tall order.
It is.
But if there's one thing I've learned from this deep dive, it's that the universe is full of surprises. And we humans have this incredible capacity for ingenuity and adaptation.
Yeah,
So maybe we can rise to this challenge.
I hope so. We've covered a lot of ground, though. Maybe you should take a second to let all this sink in before we jump into the final part of our exploration.
All right, we're back for the final part of our deep dive into the mathematical universe. I
Uh,
feel like we've gone through a crash course in theoretical physics and philosophy all in one. We went from equations making up reality to a potential multiverse, and then this awesome responsibility that comes with it.
yeah, it's been a wild ride for sure.
It really has. So as we wrap up, where do we go from here? What are some of the key takeaways you hope listeners will, walk away with?
Well, first off, I think it's important to remember that even if the universe is a mathematical structure, it doesn't make our existence any less amazing. Think about it. Everything we experience, see, feel at all, comes from these elegant and profound mathematical relationships. It's kind of like discovering a beautiful piece of music is based on complex harmonies and mathematical ratios. It adds this whole other layer of wonder to the
I
experience.
love that analogy. It's not about, reducing the universe to just cold, hard equations,
Mm.
but appreciating the beauty and complexity that comes from those building blocks.
Exactly. And secondly, I think Tegmark's ideas really encourage us to think bigger, to embrace this more expansive view of reality. The possibility of a multiverse with all its infinite variations pushes us to be more open-minded and really question everything we thought we knew.
It's like you're saying that the little patch of sky we see at night is just a tiny glimpse of this vast cosmic tapestry, with countless stars and galaxies beyond our reach. It makes you feel small, but also connected to something so much bigger than ourselves.
Absolutely. And finally, and I think this might be the most important takeaway, we have to consider the ethical implications of this perspective. If we truly are rare in this universe, then we have a responsibility to act as stewards, not just of our own planet, but of knowledge itself.
It's not enough to just discover what's out there.
Right.
We have to protect it, nurture it, and ensure its continued existence. It's like we've been given this incredible gift, this chance to explore and understand the universe, and now we have to prove ourselves worthy of it.
Well said. It's a call to action that goes beyond just science. It touches on our values, our beliefs, our responsibility to future generations and to the universe itself.
This whole deep dive has been a whirlwind of mind-bending concepts and profound questions. I'm left with a sense of awe, but also this renewed sense of purpose. We may not have all the answers, but we're a part of this incredible journey of exploration and discovery.
And who knows what amazing discoveries are still waiting for us out there. Maybe one day we'll even have evidence to support these ideas about the mathematical universe and the multiverse.
That's the beauty of science, isn't it? There's always more to learn and more to explore and more to be curious about.
Absolutely. And with that, I think we've reached the end of our deep dive into the mathematical universe. It's been a pleasure exploring this with you.
Likewise. For our listeners, we want to leave you with one final question to ponder. If the universe really is a mathematical structure, does that make us part of the equation? What does that mean for our understanding of consciousness free will? Our place in this grand scheme of things? Keep exploring, keep asking those big questions, and never stop being curious about the universe and our place in it. Until next time, happy diving.